I'm going to take a look at what are called imaginary numbers. And I'm going to give you the definition of an imaginary number. Imaginary numbers are defined as this, and we use this letter I for imaginary. And imaginary number, if we square it, would equal a -1. Okay, that's by definition. That's just how an imaginary is defined. That when you square this imaginary number, you're always going to get a -1. Which means if I have just plain old I, this is going to be equal to the square root of a -1. Okay, so both of these are by definition, and that is how I is defined, excuse me. So anytime you look at I, you need to know that I is equal to the square root of a -1. All right, a couple of things. If I have the square root of a -3, which we were never able to do before, but now that we've introduced I, we have a way to write this. First of all, this square root can be written as a product, and the product is the square root of a -1 times 3. And then I can break this up as two square roots, the square root of a -1 times the square root of 3. So I can simplify this expression, the square root of a -3, as, well, what is this? By definition, by what I see up here, I can replace that with I times the square root of 3. Or a lot of times you see it this way, I square root of 3, which means exactly the same thing. All right, let's take a look at another one. All right, I'm going to have the square root of a -9. Well, that's the same as the square root of a -1 times the square root of 9. Well, this is I. The square root of 9 is 3. So I have I times 3, and we write that most of the time as 3i. Very similar to 3x. This would be considered its coefficient, and this actually has a value. Its value is the square root of a -1. Now, if you've noticed, every time I've pulled out that negative symbol, I've written it as I. So I'm going to go another step further, and I'm going to write this. I'm going to have the square root of a -27. Well, hopefully you see, hey, I have a negative symbol inside the radical. I'm going to write that as just I. Now, a big mistake that people make. This is wrong. So I'm going to write wrong here. Some people write it like this, square root of I times 27. That is not correct. That is wrong. Remember, what I'm doing here is I have the square root of -1 times the square root of 27. This whole thing right here is not the square root of I. It is just I by itself. All right, so I have I, and now I have the square root of 27. And inside 27, there's a perfect square. The perfect square that exists in 27 is 9. So I can write this as 27 is the square root of 9 times the square root of 3. I look for that factor. That's a perfect square. And so the square root of 9 is 3. So I'm going to write 3i times the square root of 3. And that's what the square root of a -27 is in simplest form. All right, let me do another one. I'm going to have the square root of a -28. So this is what I'm looking at. I see the negative sign. I'm going to write I. Then I take a look. Are there any perfect squares that go into 28? Yeah, there's one. It's called 4, because 4 times 7 is 28. 4 is a perfect square. 7 is not a perfect square. So I can rewrite this as I have I times 2 times the square root of 7. How do I write that? As 2i times the square root of 7. and that is the square root of a negative 28 simplified. Right? Next one. Square root of a negative 32. Okay, this one's a little bit tricky. This is I times the square root of 32. All right, now, this is what I do. I'm going to look at perfect squares. I eliminate 1 because 1 is the perfect square that exists in all numbers. So I'm going to start with the next one. And what I do is I think of 2 squared. 2 squared means 4 is my perfect square. 3 squared, 9. And I know 4 goes into 32, but I'm just going to go on to see if there are bigger ones. 2 squared, 3 squared, 4 squared. Does 16 go into 32? Yeah. And what you're going to do is look for the biggest perfect square that's a factor. The next one is 5 squared, 25. That does not go into 32. The next one, 7 squared, 49. Well, 49 is way too big for 32, so I'm going to stop here and I'm going to rewrite this as I times the square root of 16. 16 times what is 32? 16 times 2. So I have I times 4 times the square root of 2, and I'm going to rewrite that as 4i times the square root of 2. Okay? Next one. I'm going to clear this screen. And I have a negative 3i times I. All right, well, let's take a look at our definitions. I start out in the very first part of the video saying that I squared is equal to a negative 1, and that I, or I to the first, is equal to the square root of a negative 1. So if I look at this, I have a negative 3 times I, because I times I is going to be I squared. What's my definition of I squared? It's a negative 1. So I have a negative 3 times a negative 1, and I get 3 as my answer. All right, let's continue on that. All right, I have the square root of a negative 12 times the square root of a negative 2. In solving these, the first thing I do is I take out I, and I'm going to write the square root of 12 times I times the square root of 2. So the negative signs that were inside this radical became I. The negative sign that was inside this radical became I. And then there is a perfect square that's a factor of 12. It's called 4. So now I have the square root of 4. 4 times 3 is 12, and 3 is not a perfect square. And all this is multiplication, by the way. There's no addition going on. Times the square root of 2. All right, so what do I have here? I have I, and I can rearrange these, times I, times the square root of 4, times the square root of 3, times the square root of 2. Well, this is going to give me I squared. This is going to give me 2. And this is going to give me the square root of 6. Because they're both inside this radical, I can multiply them. And 3 times 2 is 6. Now I squared was a negative 1 times 2 times the square root of 6. And so I'm going to get a negative 2 times the square root of 6 as my answer. And that is the product of these two right here. All right? Let's look at another one. Let's say I have the square root of a negative 36 times the square root of a negative 45. The first thing I'm going to do is I'm going to write I times the square root of 36. Remember, this is times right here. Times I times the square root. Now I'm going to look at 45. Is there a perfect square that is a factor of 45? All right, let me write my perfect squares. 4, 2 squared. 9, 3 squared. Ooh, 9 goes into 45. 16, 4 squared. No. 25 does not go into 45. 36 does not go into 45. 49. All right, so my choice is going to be 9. So I'm going to write the square root of 9 times the square root of 5. Again, 9 times 5 is 45. All right, what do I have here? Well, when I multiply those two together, I'm going to get I squared. And I squared, again, is a negative 1. The square root of 36 is 6. Notice my multiplication symbol. The square root of 9 is 3. Notice my multiplication symbol times the square root of 5. So, negative 1 times 6 times 3 is a negative 18 times the square root of 5. And that's my answer.